This is Algebra 2, problem 2-10. In this problem, we're given the fact that we have a point, -3, -1, and a slope of 5, and asked to find out what would be the coordinates for the other point that starts with the input of 2. So here I've graphed this problem, and here we have the point -3, -1. And I put a vertical line here where x equals 2 because I want to know what the line that's going to go through this point, -3, -1, that has a slope of 5, and where is it going to intersect at this where x equals 2. So I started counting up the slopes, going up 5 and over 1. And lo and behold, right here is where it crosses and touches this line x equals 2. I just kept doing the slope, up 5 over 1, up 5 over 1. Notice that my scale, I have a longer or wider scale on the x-axis and a closer scale here on the y so that it would fit in my graph paper properly. And I'm going to connect those points, and there's the line. And when I look at what this point is, I went over to 2, but I was all the way up at 24, so I know that that is the output. When the input is 2, the output will be 24. This is just doing it kind of a graphic way to see this problem. Notice now that the distance from the height, that I went up to 24 and I went all the way down to -1, well, that height change is 25. And here the horizontal change from where I was at -3 and I went all the way to +2, that is a change of 5. Well, that creates a right triangle where the two legs are 5 and 25, and we're here to find the distance between the 2 points. Well, the distance would be the hypotenuse of that right triangle, so I use the Pythagorean theorem, and taking the square root of both sides to find the actual distance. And this is the Pythagorean theorem, and the distance formula for 2 points on a line are related. So we've got the Pythagorean theorem here. This is the distance formula where it says the distance is equal to the square root of the change in my y's squared plus the change in my x's squared. And I got the change in the y's here and the change in the x's here. So I find that the distance is a square root of 650 with a calculator that is approximately 25.5.